We now continue with part 4 of the slides. We are on slide 16. We will now introduce the foreign sector, thus making our Keynesian model a four-sector model. Please refer to section 7.2 in the second edition of the Understanding Macroeconomics textbook. For those using the first edition, please refer to section 5.4. In order to include the foreign sector into the Keynesian model, we have to include exports, and we will denote it with the letter X, and imports denoted with the letter Z. As South Africans, we do not only spend on domestic products. Similarly, part of the domestic production is exported, and the spending of these exports comes from the rest of the world. From chapter 1, you know that exports are an injection into the circular flow of income and spending, and imports constitutes a leakage. Because the last two terms both relate to the country's links with the rest of the world, they are often joined together in brackets. So typically we would put brackets around the X minus Z. The difference between exports and imports is usually referred to as net exports. Let's begin by asking what determines exports. Ultimately, the demand for South African exports depends largely on economic conditions in the rest of the world, our international competitiveness, and exchange rates. There is no systematic relationship between the level of exports and the level of income, Y, in the domestic economy. We can therefore assume that exports are once again autonomous with respect to total income, Y. Exports, or X, is equal to X bar, where the bar above the X indicates that it is autonomous with respect to Y. Graphically, the relationship between exports and income is illustrated by a horizontal line, as in the figure on slide 18. So let's quickly look at this figure. We would have to place exports on the vertical axis, and total income is on the horizontal axis. Exports is autonomous, hence the X for exports has a bar on top, and we draw it as a horizontal line. So X is equal to X bar. The fact that it is a horizontal line tells us that it does not matter what the level of total income would be in the economy, exports would be independent of that. The introduction of exports thus would serve to increase aggregate spending on domestic production, ceteris paribus. Exports do not affect the size of the multiplier. However, the addition of exports sets the multiplier process in motion and will result in an increase in the equilibrium level of income that is greater than the original increase in exports. Imports. The South African economy is an open economy that is dependent on imported capital and intermediate goods. About 80% of South Africa's imports consist of capital and intermediate goods. When spending and income increase in the domestic economy, this results in an increase in imports. Thus, there is a positive relationship between domestic economic activity and imports. If income, Y, is the main determinant of imports, Z, then the import function looks something like the consumption function. Imports have an autonomous component, Z bar, as well as an induced component, MY, where M is the marginal propensity to import. M is the marginal propensity to import. Thus, the imports function is given by Z, referring to total imports, is equal to autonomous imports plus the induced imports, or the marginal propensity to import multiplied by y. So the M indicates that the fraction of any increase in domestic income that is spent on imports. Remember that imports represents a leakage from the circular flow of income and spending. When we spend on goods and services produced internationally, it means we're reducing our spending on locally produced goods and services, ceteris paribus. Whereas exports are added to the components of aggregate spending, imports need to be subtracted. Taking both exports and imports into account, aggregate spending can therefore be written as C plus I plus G plus X minus Z. In an open economy, a smaller portion of any increase in income is passed on each round of the multiplier process. That is, the multiplier becomes smaller as a result of imports. So let's look at our model that we currently have. So from our inclusion of the government sector, we still have disposable income being YD. YD is equal to Y minus DY. And we rearranged such that we collected our terms and we had in brackets 1 minus D close bracket Y. Substituting that into our consumption function was now given as C bar plus a marginal propensity to consume multiplied by disposable income, which was given by 1 minus T in brackets 1. Now we have our imports function, which is given as imports Z is equal to Z bar, which is your autonomous imports, plus your induced imports, which is given by M, which is the marginal propensity to import, multiplied by Y. We still have our equilibrium condition, which states that A is equal to 1. Thus, we know for our components of A, like I said, A is equal to C plus I plus G plus X minus Z, because Z imports is a leakage. We can now substitute the various components for these symbols. Right, so here we have our consumption function substituted for C. We have our investment spending function, which is autonomous. We have our government spending, which is also autonomous, plus our autonomous exports. And note, this is important, we have to say minus imports. This is the entire import function Z. So when we substitute, we have to obviously multiply into the bracket, so that becomes minus Z bar, and distributing negative multiplied by a positive, this will also become minus MY. Thus, we of course want to solve for our equilibrium level of income Y, so it would make sense for us to group all our variables or terms that have a Y attached to it. So if we look at this over here, this term has a Y, that term has a Y over there. If I'm going to take it over to the left-hand side, this sign is going to have to change as well as that. So hence this becomes minus C in brackets 1 minus T close bracket Y, and this becomes plus MY. And what we left out on the right-hand side is all the autonomous components. So this represents total autonomous spending. So you have C bar, I bar, G bar, X bar minus Z bar. So now I would like to collect all my terms together, right? So by doing so, here we go. By doing so, I end up having, remember there's a 1 in front of this Y, and if I take the Y out, I end up having 1 minus C in brackets 1 minus T plus M, right? So if we take all of this now to the right-hand side, because this is multiplicative, if we take it over to the right-hand side, it becomes the inverse, and it becomes 1 over 1 minus C in brackets 1 minus T close bracket plus M. This represents your multiplier or alpha, and in the square brackets over here, we have the total autonomous spending. Note, this is A bar. So our equilibrium level of income, Y0, can be calculated by saying the multiplier multiplied by the total autonomous components of spending. Right? So take note, the multiplier now has a new term M, the marginal propensity to import. Since it is below the line over there, it follows that the greater M becomes, the smaller the multiplier will become. That is very important because taxes as well as the marginal propensity to import, the way they enter the multiplier determines how it will affect the size of the multiplier as well as your marginal propensity to consume. The import function z is equal to z bar plus my, and it's shown graphically in figure A along with autonomous exports. The vertical intercept of the import function z bar represents autonomous imports, while the slope of the function m represents the marginal propensity to import. X bar represents exports, and we know that it is a horizontal line drawn against total income. Note, there is only one level of income where exports are equal to imports. That is where net exports are zero. That is at that point over there. This represents the level of income at which the balance on the current account of the balance of payments is equal to zero. And this we denote with YB. Note that in figure B, we have net exports on the vertical axis. So net exports is shown in this figure, in figure B. At YB, we can see that net exports is in fact equal to zero. And at income levels lower than YB, we find that net exports, which is X minus Z, which is drawn by this figure, we see that it is in fact positive. So at income levels lower than YB, net exports is positive. However, at income levels greater than YB, we see that net exports becomes negative. And this makes sense because imports will increase as income increases. And hence net exports, which is the difference between exports minus imports, that will of course fall. In figure C, net exports are added to the other components of aggregate spending, C plus I plus G. The aggregate spending function before the introduction of the foreign sector is represented by A. When net exports are added, the intercept and the slope of the aggregate spending function changes. In the figure, net exports are positive when Y is 0. The vertical intercept of the aggregate spending function therefore increases from A bar to A bar 1. The slope of the aggregate spending function becomes smaller than before. You can see that this slope of the new aggregate spending function A1 has become flatter since leakages increases as income increases. The new aggregate spending function intersects the previous aggregate spending function at YB, that is where net exports X minus Z is equal to 0. The original equilibrium at E0 is given with an equilibrium level of income Y0. In this example, the introduction of the foreign sector reduces the equilibrium level of income to Y1 at E1. This is not, however, necessarily always the case. The actual impact will depend on the position and the slope of the net export function. The only result that will always hold is that the introduction of induced imports into the model reduces the size of the multiplier, as we have indicated earlier.